Alright, welcome to the TROOPERS23 Shitty Add-on Soldering Challenge. This shitty add-on will allow you to plug a Nintendo game controller from the SNES into your badge, and it will also display some pretty patterns of LEDs that are unique to you. Right, in order to solder, you need three things. You need heat, which comes from the soldering iron. You need solder, which we've got here in wire form, and you need flux, which might not be so obvious. So flux, which also comes included inside the solder, but we've also got it available in a pen form as well. Flux allows the solder to flow properly and to wet the surfaces of the metals. And it does this by reacting with the oxides that form on the metals and kind of cleaning them away. The second thing I want to tell you about soldering is that soldering is not painting. It might be intuitive to sort of add some solder to your soldering iron, like this, sort of melt a bit of solder onto the tip, and then try and, say, transfer it to your joint. So got a bit of scrap PCB here. You'll see if I just try and transfer that blob of solder onto the PCB, it does stick, but it doesn't really want to sort of flow and wet the surface that easily. On the other hand, what you should do is just simply use the soldering iron to flow heat into the joint. Oh, and I should say, in order to do that, it's important to have a little bit of solder on the iron. But that's not the solder we're going to use to make the joints. That's just to help the heat flow. You then allow heat to flow into the joint, and then you can just flow solder onto the joint. And you can see now that solder really wants to just flow nicely over the whole surface of the metal like that. So that's the difference between painting and soldering. So let's get started. First off, check that you've got all the parts. You need a Nintendo connector, the PCB, a pin header, 4 LEDs, and 1 capacitor. There's a couple of spares. Now, my board is green, just ignore that. This is a prototype. Okay, we're going to start with the surface mount parts. Let's do the LEDs first. They're probably the easiest parts to place. So each time you pick up the iron, give it a wipe on the sponge. That'll hopefully leave the tip nice and shiny. Then put a little blob of solder on the tip, just a tiny bit. That helps with the heat transfer into the joint. And then I'm just going to put a little blob of solder on the first pad there. And then I'm going to pick up one of my LEDs with the tweezers. And you'll see that it has a dot on one corner. You want to make sure that the dot is at the bottom left. There should have been a mark printed on the PCB, but I made a mistake. So just remember, dot, bottom left. And then yeah, just heat up the blob again, and then just slide the corner of the LED, slide that leg into the blob. Try and get the LED roughly square and roughly centered, and then put a little bit of downward pressure, and then just reheat that joint and take the iron away again. That second step with that downward pressure just makes sure that the LED is flush to the board, which makes soldering better, and it just improves the general quality and appearance of your work, which is always key, I think. Cool, and then we're just going to solder the remaining 3 legs. So just arrange the board so that it's comfortable for you, and then just again heat up both the leg and the pad, and just flow on a bit of solder, and you'll see that it'll just flow up the leg and the pad, and that's a nice joint. Do it one more time, this side. Now, you'll kind of get a feeling for how much solder you need. Try not to put too much on. Less is more in soldering generally. That's kind of a perfect amount where you've got that nice smooth transition like that. You don't want a big spherical blob there's always a hazard that might short circuit onto the neighbouring component or something, or and you can also have the condition where you're not exactly sure that the blob is actually touching the pad. Sometimes you can have a blob that's sort of floating on a layer of flux. So you want that kind of smooth transition, that kind of meniscus effect. Cool, and then we'll just do the third one. Same again, it's a little blob of solder on the iron just to help the heat transfer, heat up the leg and the pad, and just flow on the solder like that. Don't be in a rush, there's no need to be in a rush. As long as you're adding fresh solder, then you're adding the flux, it's not going to boil away too quickly, so because you're adding it directly to the joint, so there's no need to rush. It's much better to do things slowly and calmly and precisely. And now that first joint, you'll if you heat up a joint for a while, the flux gets driven away and it boils away, and the quality of the joint is not as good. The joint, the solder doesn't flow over the whole surface, and you can kind of see there that the leg is less covered, and also you can see that one joint is nice and shiny and the other one is kind of matte. And the longer you heat a joint and kind of manipulate it in the absence of flux, the more it sort of behaves like clay and not sort of like water or like liquid mercury or whatever, if you ever played with that. So what I like to do, once I've done the 3 remaining legs, I just come back and I add a little bit more solder. And that's not really because you need any more solder, it's just because you need some more flux in that joint. And then you'll see it's as shiny and nice as its neighbour. So that's the process. So we'll do another LED. So just heat up that pad, flow on the solder, then grab an LED, bring it over, heat up that pad, and just slide the component leg into position. I'm looking on the camera to try and get it to square. It's pretty good. Bit of downward pressure. Heat it up again just so that it's flush to the board. And then I'll just heat up both the leg and the pad and just flow on the solder like that. Same there. You can see that's a pretty good amount of solder there. And the same again. Third leg, heat up the pad on the leg, flow on the solder. And then that first joint, you can see that's a very poor quality joint there. It's just barely tacked on. So you definitely need, well, in this case, I definitely need to come back to that joint and add more solder and flux. And there we go. That's a nice joint. Let's do the 6-pin header, why not? So again, same process. Going to heat up the first pad, put a blob on there. Now before I solder this on, I'm just going to say I should have probably, well, I definitely should have insulated this track here. It's going to be very easy to accidentally bridge that joint there. So put a blob that spans across and accidentally gets on that track. So please try to avoid it if you possibly can. But if you do it, hey, it's not a problem, we can fix it and I'll show you how. So heat up that blob and then just slide that component in. You can either use tweezers or your fingers. I find these bigger parts, it's a bit easier with fingers, but up to you, don't burn your fingers. Oops. Now I'm trying to get this as square as I can, because if it's not square it won't hang from the badge nice and square. So yeah, that's not square, as you can see. It's kind of difficult doing it down the camera, but we'll try. Done pin 1, connect to the square. I'm going to do all the other pins. Don't forget to regularly clean your iron on the sponge. And always make sure you have a bit of solder on the tip of the iron. Okay, so, and then I'm going to go to pin 1 here and tighten that up because I heated that for ages. Okay, cool. And I'm just gonna accidentally make a big mistake here and flow. Oh no! I've just flowed loads of solder on there. What a disaster! No. So you can see I've got a problem there. I've got a big blob of solder, and it's flowed onto this wire here, this track, and that's going to stop my project from working. And I'm going to test it with the multimeter, just so that you believe me. So I have the multimeter here. If I touch the pins together, the probes, it beeps, and you can see that this track, which comes up from the leg of this LED, is now shorted onto this pin. So what are we going to do about that? Well, luckily, somebody invented this stuff, which is called desolder braid. And this is like the wick of a candle. It's really absorbent. It's made out of woven copper with flux impregnated into the weave. And it works really well for sucking up excess solder. So here's the desolder braid. Looks like candle wick almost. Sometimes this particular solder wick's a bit crappy, so I like to add a bit of extra flux to it. Then I'm going to add a load of flux to the problem area. And having more flux around just makes the solder want to flow more easily. And then what I'm going to do is I'm going to lay the solder braid on top of the joint, and then I'm going to heat it from the top. And if I get the camera in the right place, you'll see as if by magic the solder starts to flow up the wick. And I'll just keep the heat on there while it's flowing. And you have to kind of guess when is enough time, and I reckon now's enough time. And as if by magic, there we go. There's now, you can probably just see there's a gap again between that leg and that track. But it's very easy to take away too much solder, so just so that we're certain that we haven't done that, I'm going to revisit that pin, just add a little bit more solder. And then I've also sucked a bit too much away from the LED leg as well, so I'm going to just come up to that LED leg and just add a little bit more there as well. And there you go. So don't panic if you make a mistake, if you solder something together, if you solder the wrong part on the wrong blaze, if you solder a part upside down, around the wrong way. There's always a way. There's always a way out. So just ask one of the helpers, and they'll be happy to give you some tips and get you unstuck. So there you go. And just so you believe me, if I just beep these probes together, And then we do the same test again, so from the leg of the LED and touch that pin, no trouble. Next, the capacitor. So here's one of the caps. Pretty easy to lose these components, by the way, so try not to, but we do have spares. So same process again. I'm going to again put some solder on the iron, heat up one pad, flow a little blob onto the pad, grab the capacitor, heat the blob and just slide the capacitor in. Then come around the other side, heat up both the pad and the capacitor, and there we go, and that's a good amount of solder on there. If you put on too much solder, it's okay if you know that it's not touching anything else, or and you know that it's definitely touching the pad. But if you're unsure, you can just remove it again with the desolder braid and make the joint again. And then, as before, I'm just going to revisit that first side of the capacitor there. Just heat that up again and just add a bit more flux that way. So that's the capacitor placed. Okay, so the last step is the Nintendo connector. As it says here, mount it on the other side. Very important not to mount it on the bottom. And just make sure, be gentle, make sure all the legs are in the right holes, don't force it. And you'll see the 6 legs engaged there, and then just push that home. So that's how it should mount there. All the legs in the holes, nothing bent. The connector's got a bit of mass to it, so you need to get a bit of heat into it. So particularly the shell, so that's these 4 outer joints. So you want to make sure there's a good amount of solder on the iron, and you also want really good contact between the iron and the pad and the leg all at once, and then just flow that solder in. Again, no need to rush it, and that's what we're looking for there. Again, you've got that nice kind of meniscus, not a big blob, but a good amount of solder. And the other side as well, so again, good amount of solder on the tip, so it's nice and wet, so you get nice heat flow into the joint. You want to position the iron so there's good thermal contact between the tip and the leg and the pad, and then just flow in the solder like that. Same over here. Heat the leg, heat the pad, oops, and then flow in that solder. Cool. And just have a look around, make sure those joints all look neat. If there's a little hole where you haven't got enough solder or something, you can just heat that joint up again, add a bit more. Yeah, I'm happy with all of those. Right, and now we'll just solder the rest of them. There's nothing special to this really, same process. Obviously try and avoid bridging them together. You know what, let's see if we can bridge a couple, and then we'll see how to recover from that. They're actually pretty far apart, so they're probably quite hard to bridge. If I get this in the right spot, I can probably bridge these two. So there you go. So if you've accidentally got a big blob on there, generally, if you just clean your iron so there's nothing on the iron, and then just draw draw the iron through there. Sometimes you can just drag the blob away like that, and that's worked pretty well. And then you can see that it's sort of transferred onto the iron there. You can then just kind of keep using the iron to just sort of wick away. A bit like using, well, I don't know what it's a bit like, but yeah. There you go. So those joints are now, I would say, okay. They're not the most beautiful. There's a bit too much solder on there, but I can definitely tell that they are actually connected to the board. I'll just do the rest of these joints. And that's pretty much it. So you can see those joints are all in, what's the word? They're not bridged together, there's not too much solder, there's no spheres, there are no gaps, there are no holes. Job done. If you don't like this flux residue, you can clean it off with some isopropyl alcohol, some methanol, flux remover, lots of different things, mostly alcohol based. Will clean that off nicely, but it doesn't impair the function of your circuit at all, so no biggie. Okay, so there's your shitty add-on complete. Thanks for watching. If you have any questions or if you have any trouble, feel free to ask one of the helpers and they'll help.